start by writing the function memoize fn. Now, this parameter fn is the function to be called or to be memoized. Now, first thing, because we know this will be called once and it will return the memoized version of this function. So first, inside here, we will set the cache object in it. So we'll do something like this: fn dot. So this line, what it does is to create a cache static property inside the function. Yes, and then assign it to here. If the cache static property already exists in the function, it assigns it to it. Or if it doesn't exist, then it creates a new object literal. So now we return a function. Very good. Now this is not the function to be called, so it's an unnamed function. Now let's use rest to gather all the arguments that will be passed to it, because we don't know the kind of arguments that will pass to it. So we use nest to gather all the arguments inside an array. So this args will have all the arguments passed to this function as an array. Now the next thing we have to do is to now do the memoization logic here. First thing, like always, we'll check if the cache has the arguments being passed, then we'll return it. Then, if not, we'll just assign the cache to the args. Now, assigning, we're now using the arguments now as the property, so we'll now call the function. So we'll now say fn.apply. We'll now pass this and then the args here. Then we'll now return the result here. So we have completed our custom memoization function. So what we did here first, this function will return another function. So it's something like a higher order function. So first in this first code, it assigns the cache static property to the function being called. If it doesn't have it, it creates a new object literal. Then it returns the function, makes all the arguments into a rest to be stored in these args. Now first the memoization logic now goes here. It uses these args as the key object in the caching logic. Now this args becomes the key in the cache object. Now this arg stores all all values of any function called here. So that was it. So the function being called here, the cache will now be stored inside the function. So each function being called here inside here holds the cache. So there will not be any possibility of conflicts of cache, or maybe another cache was assigned to another function. No, because of this closure here, so we are able to get the current function being called here. So we get it, we create the cache or check if the cache contains the args. Then if yes, we return it. Then what we're returning here is the value inside the cache using the args as the key. Then if not, we'll run the function. We'll run it passing the arguments. Then whatever result we get from it, we'll create a cache, create a key using the args, and assign the value to be the result from the function execution. Then last, we'll just return the result. So that's it. Now let's see this memoization logic in function. So let's create our square function and just say number. So to see that this works, let's just add some console log here. Cache hit. Yes, let's use for, let's pass args here. And also let's say no cache hit. So we will now call the memoize function with this square. So because we know it's returning a function, so we just name the returned higher order function memoized square. So we'll just call memoize and pass the square. So now we can now call our memoized square function with now the values we want to square. Now this memoized square now is this function. So it will now call this our square function. So it's just a memoized version of this our square function. So let's now test it. Let's see here 90. Now let's run it. So you see it. No test. Now for 2 and 4 there is no hit because it's the first they are the first inputs. The memoized function, I have not seen it before. Then the second one, there was not a cache hit for 2. Now for 90, no hit at the first call. Then the second one, then there was not a cache hit for 90. So you see it. Now we can also have another function. Let's say multiply function that multiply a number by 90. So we can also do the same. We can also memoize the function. You can just say cost memoized multiply. So we just call the memoize, then pass the multiply function. Now we cannot come here and now call the memoize multiply. Now this memoize multiply is not a memoize version of this. So we can just call it with now the argument 45, 90, 45, 45, 70, 70. Then like this, let's clear the terminal. So you see, it works also. No hit for 45 and 90. Then on the second one, there was a hit for 45 and 45 for again. Then no hit for 70. Then on the cache hit for 70 also. So you see how we have now created a custom memoized function. So there is no need of we memoizing every function that we create in our application. So we can just simply pass the application we want to memoize into this function and we get a memoized version of it. And also remember that for us to memoize a function, it must be a pure function that does not depend on any other external variables or global variables. And also the input must be dependent on the output. So the input must be dependent on the output so that it can safely memoize it, because the memoization works based on the input and also on the operation and the return of the operation. Now, memoization should only be used on a pure function whose input depends on the output. Now, if the input does not depend on the output, or let's put it this way, if the input depends on the output, but the output is unpredictable, now memoization cannot be used on it. Let's look at this code. Now see it, we call it unpredictable. Now this function is unpredictable because we have a date here, date.now. Now this date.now, looking at it, see it returns the number of milliseconds elapsed since midnight. So it returns the current date just right now. In fact, the date it returns now will not be the same date it returned right now as we are speaking now. Just the previous millisecond there ago is not the same. So you see, this changes over time. It is not static. So in as much as this unpredictable, whose input depend on the output like this, seems to be an eligible candidate for memoization, but it should not because of this unpredictability here. It cannot be memoized just because of this, because this changes over time. So if we store the input here and try to run this again, we will not have a stale data because the next time we are running, we have elapsed a microsecond or a millisecond or a nanosecond. So it will not be the same. It will invalidate the cache. So we have to be refreshing the cache every time. So refreshing the cache almost every time is basically means we don't need the cache anymore. Yes, because this periodically, almost every call of it returns a different output of this date dot now. So this is a use case whereby we cannot memoize a function, even though it is dependent, its input is dependent on the output. Now, let's look at a real world use case whereby we can use this memoization and it will prove very effective. Now, we'll be trying out the Fibonacci series. Let's clear this out. Then let's leave our memoization, our memoize function for now.